Hello everyone, myself V.V.Gopala, Assistant Professor, Department of Computer Applications, Aditya University. Today I am going to tell you about random access protocols related to CSMA. After completion of the lesson, we are expecting the outcomes from the students like this. So student may be able to know about what actually the role of multiple access and what are the protocols meant for multiple access, and also about random access protocols, what actually the meaning of random access and what protocols are there for satisfying the random accessibility. And in that, what are the different protocols like CSMA, and you know about the details of CSMA, also followed by CSMA bar CD, that means carrier sense multiple access, and collision detection. CD stands for collision detection, and CSMA bar CA. This is nothing but carrier sense multiple access with collision avoidance. So these are the things we are expecting to cover in this lesson. So we hope that the student may be able to know about the fundamentals of the factors. Okay, let us start with what actually the use of multiple access. What actually the basic idea of multiple access? So it is only to increase the efficiency of the channel. So this particular multiple access concept is introduced. That means if you have a channel, and if the channel is dedicated to only between two users, then it is very expensive to maintain the channel among several users. So that we keep one channel, and which can be shared by certain devices, then automatically the sharing of channel can be considered as a multiple accessibility, where the sharing is the main point or the criteria where we are allowing that to by the users, so that they can share the channel commonly and they can transmit the information from one side to another side. So that is called as a multiple access. So in that there are several protocols, but we are focusing on the random access protocols. So here the random access protocols are nothing but you can able to access the channel on a random basis, and based on the actual the availability of the channel for transaction, so the station can able to send its data or transmit its data from one end to another end. So that is actually the main point of calling it as a random access. That means randomly the stations can access the channel, and when the channel is free, then they can able to send their data. So that is actually the point in this random access protocols. So in this there are certain protocols, already I am introduced that CSMA, CSMA bar CD, and CSMA bar CA. So these are the basic protocols, but the basic idea is they have to follow the concept of the procedure of CSMA. The CSMA stands for carrier sense multiple access. Here the carrier means nothing but the channel, what you can call. So here, before sending any information or before transmitting any information, so every station has the opportunity to sense the channel. That means sense in the sense it is nothing but it has to see whether the channel is idle or busy. So that is the activity we call it as a sensing. So in this CSMA, every station is supposed to sense the channel before actually transmitting the actual information. So that is why this particular protocol is referred as a CSMA, carrier sense multiple access. Multiple access is the main concept actually we are talking about, and in that we are talking about random access protocols. In that CSMA is one of the important protocols we are discussing, where every station has to sense before actually sending the information. So that is the main point we have to consider in this case. Why it has to be randomly sensed? Because it is related to random access. Because if you continuously or if you fix the time intervals for sensing the actual channel, so there may be possibility of collisions. So that is why we go on a random basis, so that the collisions may be decreased. So that is actually the point of talking about random accessibility. We are going to discuss about why the channel is randomly sensed, and what is the main reason of going for random accessibility like this. So even though there are certain things which are actually following based on the CSMA, even then because of propagation delay, so still there may be some chances of collision here. If you see the slide, there is an example here. Suppose A is a station which is trying to okay, send some information. Before that, as far as CSMA is concerned, it has to sense the channel, whether the channel is idle or busy. So but fortunately, when A is sensing the channel, it is noticed that the channel is idle. Then it is in an impression that because it is idle, so it can transmit the data. But because once it is released the data, once the first bit that is traveling from its side A, then it is traveling to some destination called D. Let us say D is the destination. Let us imagine like that. Then once A is releasing its data, once it is actually releasing the first bit of A. Once it is crossing to C, once it is crossing C before reaching D, so there is D. C also has some data to transmit, and it is once it is sensing the channel, it is noticed that it is idle. Then it is in an impression that because the channel is idle, then it can also put its data for transmission. But the first bit, when it is reaches to C, even though A has released the first bit at the time of sensing the channel because it is free, but whenever it is reaching to C say, station, then C is also okay putting its data, then definitely there is a chance of collision at this location. So it automatically corrupt the whole the transaction, so because of the collision. So A's data is not useful, and C also can lose its data because of the collision. So this is because of propagation delay. That means propagation delay is nothing but the delay taken into consideration while traveling from A to the other stations. Whatever the time that is taken up by the data to travel is called as the propagation delay. It may be due to some technical problems, or it may be due to some kind of routing problems. So the propagation delay may be possible. Because of the propagation delay, once the stations are sensing the channel is idle, but once they are actually talking, or when actually they start the transaction, so still the collisions may be occurred. So that is why, even though we follow random access protocols and especially CSMA, still there is a possibility of collisions. But we are going to follow certain principles, certain procedures. Based on that, we are trying to reduce the collisions. We cannot avoid all collisions every time, but we try to reduce the number of collisions that may occur in the transaction. So that is about the effect of propagation delay in the case of the actual random access protocol, especially in CSMA. And of course, CSMA is following certain persistence methods. So in that, there are three types of persistence methods we are noticing here on the board. So that is one is called as one persistence method. Here one stands for the probability of probability of collision. So here the probability is maximum, or the probability is more, or the probability is of occurring a collision is very high. That is why it is called as one persistence method. In this, if you see this, there is a station. Imagine that there is a station which is which is allowed to continuously sense the channel here. So that is the meaning of continuous sensing of the actual channel. So why it has to continuously sense? Because it has to find out whether the channel is idle or busy. So once it is continuously sensing, at every moment it is identifying that the channel is busy, then it goes on continuously sense it, and after some time the actual station may notice that the channel is idle. That time only the station is allowed to put its data, because it is noticing that the channel is idle. So this is actually called as the one persistent method behavior. So if you see the flow chart, it is more clear. So actually, what is the actual flow of process is shown here. In this, let us imagine that the process of sensing is shown from the upper arrow. It is actually sensing the channel, and once the channel is busy, let us say there are two options: the channel may be busy or the channel may be idle. So once the channel is busy, so then again the station is allowed to go for one more trial. So like that, continuously it is happening till the channel is giving a response called as an idle response. Once the channel is saying that it is idle, then only it can transmit, the station can transmit the information from its side. So this is the actual flow process of the one persistence method. But here the possibility of collision is very high, because you are continuously sensing, but once you say that the channel is idle, that time okay, it may be idle, but once the moment you start the process, the other station may also put its data, so automatically they may collide because of propagation delay. So what actually you can able to improve the efficiency of the channel? So then you can go for one more method, that is called non-persistence method. In this non-persistence method, if you see the flow chart, it will be very clear. Instead of following this, better you see the flow chart, so that you can able to understand very well. So it is slight modification from the previous one persistence method to non-persistence method. Here there is the probability of collision is very less when compared to one persistence method. So that is why it is called as non-persistence method. So here, so again, if you see that there is a station which is actually starting its operation like this, it is sensing the channel from the point number 1. So once it is sensing the channel, already I told you that there are two options. The channel may give you a response called as busy, or the channel may give you a response called as an idle. So once the channel is busy, so instead of continuously sensing like one persistence method, in this particular non-persistence method, the station is allowed to wait for some time on a random basis. That is a change in this. So we are allowing the station to wait randomly. So because of random waiting, instead of fixed waiting, if you go for a random waiting, so because every station may go for a random number of time interval, so there may be a possibility of less collisions because of random time intervals they are noticing. So that is why wait randomly, we are allowing the station to wait on a random basis, and again you sense the channel. So there is a possibility of noticing the channel idle, and at the time once you notice the channel is idle, then only the station is allowed to transmit the data. So that is why this non-persistence method is a slightly modified version of one persistence method. In this, the waiting time is on a random basis, we are following this. That is why it is called as a non-persistence method. And of course, even then the stations are waiting are allowed for a random basis, but even then there are certain chances of collision. So we better go for one more method, that is called the P persistence method. Here P is the probability value, which is a predetermined value that is actually calculated before starting of this process. So let us say P may be some value called let us say 0.6. Let us imagine that P value is 0.6, which is calculated predetermined value, which is a probability value called. That is why this P persistent method, P stands for probability value, which is predetermined. So now if you see the actual flow chart again, you can have a better idea about what actually the P persistent method is exactly following the process. So here the channel is taken up into consideration, and which was sensed by which is allowed by the station to sense it. Let us say that is point number 1. Then the channel is noticing that the station is noticing that the channel is busy. Then you have to go on channel sense the channel again and again. So once you are saying that the channel is idle, once the response of the channel is saying it is idle, then you have to generate a random number here, R. Let us say R is a random number which is generated on a random basis. So imagine that R can stand between 0 to 1. R can be any number between 0 to 1. Okay, so this is a very important point you have to notice. So R can be a random number which is to be fixed, or which is to be generated in this process, which should be in between 0 to 1. So let us imagine that the R value what we have generated with some process is, let us say, 0.2. It is, let us imagine that it is 0.2. Now because R value is 0.2 and the probability predetermined value is 0.6, because the 0.2 is less than 0.6, so automatically you this particular point is satisfied. That means because R value is less than or equal to P, then station can be allowed to transmit the data. Suppose in other case, let us say R value is calculated and R value is estimated as 0.7. Let us say R value is a new value of random number is, let us say it is 0.7, with some process, it is derived like 0.7. Now again, if you come to this particular position, let us say you are at this position, and because r value is 0.7 and the probability value, predetermined value is 0.6, because r value is more than the probability value, then we are allowing the station to wait for some slots. So we are allowing the station to wait for some slots, and that is the point which is mentioned here, that is wait a slot. That means we are allowing the station because r value is more than p value, probability or probability value. So we are allowing the station to wait for some time slot. Then after that, again we allow the station to channel the sense the channel. Again you may get one response. It may be idle or it may be busy. Suppose still after waiting some time, still the channel is giving the response called as busy, and then you have to follow the back off process. This back off process already we have discussed in the aloha concept. So the same kind of back off process technique is to be followed here, so that once you wait the back off the actual interval time of back off process time interval, then you can able to say that the collisions may be minimized. So so in this case of actual the time slot, after waiting for some time slot, and once again you are noticing the channel, and once the channel is saying that it is busy, so we have to actually follow the back off process. No, the channel is saying that it is idle. Now the channel is after wait a slot. Suppose once the channel is sensed here, once it is saying that it is idle, then you can again come back to this step, and again you check the value of the r random value with the probability predetermined probability value, and again you have to follow the procedure what actually I explained in the previous. So this is a way how the p persistence method is more and more powerful, which is actually taking into consideration the one persistence method and the non-persistence method into consideration, which are merged here and which is called as a p persistence method. In this, random number generation is one important factor, and also probability value, predetermined probability value is another important factor. So these are playing a very important role to go for the wait slot, or to actually send the information from the station to the for the transmission. It can be identified in this case. So that is about p persistence method. But all these things are possible in CSMA, carrier sense multiple access. Here we are every time we are allowing the station to sense the channel. So that is why it is called as carrier sense multiple access. The main concept is multiple access. That means we are allowing the channel to be shared by multiple stations. So that is why it is called multiple access. We are using a technique called as a carrier sense. That means we are allowing the stations to sense the channel. And after that, we are actually having one more technique that is called carrier sense multiple access collision detection. So how do you notice whether the collision is taken place or not? If you see the actual flow chart, you can understand very well about how the collision can be detected with this procedure. Now let us start the actual process of the flow chart from this oval symbol that is called start, and let us imagine that k is a variable which is fixed a value called as a 0 initially, and apply one of the persistence methods. That means you know about one persistence, non-persistence and p persistence. Any method you follow, thereby you are going to sense the channel. That is the actual concept of sensing the or using the persistence methods here to sense the channel. So then after that, transmission will be done. And here now we are actually sensing the channel, and transmission is also done, or collision detected. So this can be possible after noticing the channel, but because of acknowledgement and because of other steps we are following, so you can able to say that the collision has occurred or not in this particular scenario. So transmission may be successfully done, or translation may not be done properly. That means collision is occurred here. So these are the two things which are actually playing a very important role to say that it is how the collision can be detected here. So now, because of this particular point, you may get yes or no answer. That means we are sensing the channel, and transmission is successfully done or not. Suppose the answer is yes, then suppose the answer is yes, then what you are saying is then here transmission done, but collision is detected. Transmission means the process of flowing the data in the channel is called as transmission. But successful transmission, when you say it is successful, once it is reaching to the destination without any collision, it can be called as a successful transmission. But here we are saying that transmission only we are identifying, but the transmission is done. But once you go for the other step, that is called any collision is taking place using transmission, it may be yes or it may be no. If it is no, that means no collision is taken place during the transmission, then the transaction can be successful. No, if the transaction is once you are saying that it is collision is detected, then you can directly go to this yes direction. Okay, so that is about when the transmission is done. And when you travel with this S option, you may, the next step is collision detection. Once the collision is not detected, then it is success. Suppose once you say that the transmission is done, for this the answer is no, let us say. So S case we completed. Now we are traveling in the no direction. Suppose the transmission done is a question, then if it is no, that means transmission is not done. Then transmit and receive. Again you have to go back to this step, and again you have to do this process until you get the answer called yes. Once you get the S, then again you have to notice whether collision is taken here or not. Once it is no, then only you can call it as a success. No, suppose the collision is detected is possibly yes, let us say. Then send a jamming signal. So here a jamming signal is nothing but a temporary signal which actually allowed to travel in the channel, so that based on the response of the jamming channel, the stations can understand whether the channel is clear or not. So that is the reason of sending a jamming channel here. So once it is done, then k will be incremented as 1, k plus 1 it is actually. Now because we started with k is equal to 0, now because 0 plus 1 it will become 1. So now the new value of k is 1. Then k should not actually go beyond k maximum. Let us say maximum k maximum value is 15. So k should not be beyond 15. So once suppose k value is going beyond 15, then you have to abort this process and you have to go after some time. Okay, then suppose k value is not more than k maximum, then you choose a random number that is between 0 and 2 to the power of k minus 1. Already you know k value. Based on that you can choose a random number between 0 to 0 and 2 to the power of k minus 1. That number is very important, r. And based on that you have to wait some time, because you are saying that the channel is already noticing some kind of collision. So we have to allow the stations to wait for some time. So to identify the wait time, so we are using this principle called as r is a random number and TP is the propagation time. So this is called as the back off time, you can call TB. TB is nothing but the back off time. You can calculate the back off time. So based on that, you come with some time interval and you wait till the time interval, and again you start the process from this step. So this is the way, this is the cycle you have to carry out till you get the success output. So that is why here in this case of carrier sense multiple access, we are using persistence methods, and also we are using one more step that is called collision detection or not, we are noticing. And once the collision is detected, already I am mentioning that this particular process is related to CSMA bar CD, collision detection. Once the collision is detected, what we are doing is we are sending a jamming signal, so to get more clarity about the clearance of the channel. So then afterwards we follow the other steps called as checking the value of k and generating the random number, and also waiting for the back off time, and again we are allowing the station to start its procedure again in the flowchart. So this way you can able to identify the CSMA bar CD, how it is going to work out. Now in this case of collision detection, how you say that the collision is detected? So you have to maintain an energy level or a voltage level of diagram like this, and whenever a collision is taking place, automatically the energy level will be doubled. So whenever energy level instead of a base instead of the normal level of energy, suppose if whenever it is doubled or it is more, then it reflects that there is a collision that is taking place. So this particular graph is showing that so how the collision detection can take place. The collision detection can be taken into consideration based on this particular time and energy graph. Whenever the energy portion is doubled, then automatically you can say that the collision is occurred. So that is the way how CSMA bar CD is going to give you some idea about how collision can be detected, what are the next steps you have to follow in this case. So then the next other procedure is called as CSMA bar CA. Here carrier sense multiple access and how you can able to avoid the collisions, that is called collision avoidance, CA. So collisions can be avoided by three strategies. One is called as interframe space, that is called IFS, you shortly call it as IFS, and also contention window. So this is another important factor you have to consider, and based on acknowledgement which is made by the actual receiver. So in this transaction, acknowledgement is also playing a very important role. So based on these strategies, you can able to say that collision can be avoided. So how? So let us say that IFS is nothing but interframe space. That means the channel is sensed by different time intervals by the station, and we are actually taking into consideration that IFS. IFS means interframe space. We leave some space or we actually wait for some time. So here, if you see the description, when an idle channel is found, the station does not send immediately the information what it has, because a distinct station may have already started transmitting, so it waits for a period of time called the interframe space, that is called IFS. That means already I told you that regarding the effect of a propagation time, propagation delay, because even though you notice that the channel is idle, but when exactly you start your process, the information that is released by the previous station may be coming to your end, and it unnecessarily disturb your and it collides with your data frame, so automatically both the data will be lost. So that is why this IFS is playing a very important role, which is called as interframe space, which is actually to allow to actually avoid the collisions by waiting for some more time, even though you notice that the actual the channel is, even though it is idle, but we wait for some time. That is the main advantage of the IFS. So thereby you can avoid the actual chance of collision here. So that is one of the important thing what I can mention here. The role of IFS. IFS is actually giving you the idea or giving you the chance of reducing the collisions, or you can also call it as a collision avoidance. And one more thing that is called contention window. So this contention window is an amount of time divided into slots. You see that. So it is nothing but a contention window is an amount of time divided into slots. So let us say that you have 3 minutes of time, let us say, or 5 minutes of time you have. Okay, this 5 minutes of time can be divided into 5 slots. So this is the meaning of the actual contention window. Contention window is an amount of time, let us say total amount of time is 5 minutes, which is divided into slots. So 1 minute, 1 minute, 1 minute slots are there, like that there are 5 slots. This is the meaning of contention window. A station is ready to send, chooses a random number of slots as its wait time. So every station is allowed to choose any number of time slots in the contention window. It is not fixed. On a random basis, the station is allowed to go for random number selection of time slots what it actually interested to wait. So that is why, so some stations may go wait for 2 time slots, some may go for 3 slots, some may go for 5 slots. So like that, we are allowing the station to wait on a random basis by taking into consideration the time slots that are presented in the contention window. Here the station needs to sense the channel after each and every time slot. That means here after waiting for, let us say I am selecting 2 time slots. Then after 2 time slots waiting time, again I have to sense the channel after each time slot. So this is the way why randomly choosing the time interval means to reduce the collisions, because if everyone is following the fixed time interval, again all the stations will start the job at the same time, so definitely there is a chance of collision. So that we are allowing the stations to go for random waiting time slots. So that is about the thing. And next is acknowledgement. We are, in addition to avoid the collision, we are allowing the station to acknowledge whether it is receiving the data in a guaranteed way or not. We are allowing the station to send the feedback to the sender, so that we can understand whether the collision is taking place or not. If the acknowledgement is not there, you can say that the collision is occurred. Then you have to follow certain procedures so that the collision should be avoided. So that is why acknowledgement is one of the important factor. Based on that, there is a guarantee that the receiver has received the information in the form of frame or not, we can able to understand. So thereby you can able to avoid the collisions. So that is why this particular CSMA bar CD, CSMA bar CA are meant for the actual multiple access in the category of random access protocols. Now I hope students are familiar about what actually the multiple access means, what actually the random access means, and what are the details of CSMA and CSMA bar CD, CSMA bar CA, where CD is nothing but collision detection and CS stands for collision avoidance. Thank you.